Hey, my name is Andre, and in previous video, this one, I showcased to you Chainlink Local, the Chainlink CCIP Local Simulator with the basic example demo in Foundry in a local environment. Well, in today's video, actually in the next series of videos, I'm gonna show you, well, everything else. So as I already said, Chainlink Local can be used with Foundry, Hardhat, and Remix ID development environments, both with and without forking actual networks, and that's what I'm going to showcase to you in this series of videos, which is going to be available at this playlist over here. So if you click down here or here in the description, you'll see the Chainlink Local documentation, and this is where we are gonna spend a lot of time in these upcoming videos because we are gonna actually use all the capabilities of the Chainlink Local. More precisely, if I go to API reference, I should be able to find details about using CCP Local Simulator with Foundry, Hardhat, and Remix ID. With Foundry, we already covered in a previous video. Now it's time for a Hardhat in a local environment. So to do that, I'll just need to, as being said here, create CCP Local Simulator.sol smart contract and copy this thing. So I'm gonna copy it. In the interest of time, I already installed Chainlink Local in Hardhat and created a Hardhat project. And then I'll just need to use it like this in my test. So this is the same as in Foundry. I'm literally creating an instance of my CCP Local Simulator contract here, and then I'm using it here to get basic config details. I'll need router addresses, link token address to deploy my contracts and whatnot. So let's get started. So as I already said in previous video, I still gonna use these two contracts. So basic CCP sender and basic CCP receiver contract, which I have over here. So CCP sender contract does nothing but sends a string, this text, and tokens using Chainlink CCIP, and the CCP receiver contract receives those tokens and then just store them in this text storage variable over here. And I intentionally put this only allow list sender modifier on top of the underscore CCP receive function, meaning that if I don't call the allow list sender function first before creating my CCP transaction, that transaction will fail. And now let's see how we will catch that error using Chainlink Local. So I'm gonna collapse both of these contracts, and I'm in a Hardhat project. So here, as stated previously, we will need to create CCP local simulator.sol contract, and I'm just gonna paste the content from the docs. Now I'll just gonna save this contract and run npx hardhat compile, so we can see that this compiles. I'll just need to use newer version of Node, but that doesn't matter really. So I'm gonna just run this thing one more time. And we can see that the contracts compile, nothing new to compile, no errors previous time, so that's cool. Now in my test file, I can easily just collapse this aside. So I in the interest of time already created a test. So here we have an instance of CCP Local Simulator smart contract, the one that we created over here, so that one. And then using config, I'm getting router and link token addresses because I need those to deploy my sender and receiver contracts. And I'm also using simulator to fund sender contract, as seen here with CCP burn and mint tokens I'm planning to send, and also with 5 link tokens I'll use for CCP fees. And then in the test itself, I'm loading these fixtures. I'm console logging the balance of CCP burn and mint tokens of a sender and receiver contract before sending the transaction. Then here, I'll intentionally for now comment this allow list sender function call, because if I don't call this function, my test should revert, and that's what we want to catch. I'm gonna just delete this. So here I'm sending tokens and data from a sender contract to a receiver contract. I'm sending hello world and 100 units of CCP burn and mint token, and then we console logging the text storage variable to see what was stored and balances afterwards. After that, we'll just need to make this task more meaningful. What I deleted, to use expect syntax to actually assert all these values instead of just console logging. But first, let's run quickly npx hardhat test and see what's going to happen. So we can see that test failed now, and if I expand this, we can see that VM exception fail, blah, blah, reverted with custom error. On the receiver side, we have this custom error. So this is the error because only allow list sender modifier true this error, meaning that only allow listed senders can send actually cross-chain messages. And this here, 7F whatever, is the address of a sender contract. And if I console log that, we should be able to see it. I'll actually console log it just for the sake of this demo. So console log, that'll be CCP sender unsafe.target, just to validate that that's that error. So if I run this one more time, we should have the same thing. And if I go to CCP receiver unsafe, we have here sender not allowed error and address of a sender. And here this only allow listed sender modifier actually throws this. And if I go to this is the address of a sender contract. It's literally this address. So that's the error that was true. What I need to do to fix this contract is literally just to call this function, and let's run npx hardhat test once again to see whether we solve the issue. And cool, we solved the issue. We saw that in literally like a second, a little over a second, we executed this test, and now we simulated the behavior of a CCP sender and receiver contracts in a local environment using Chainlink Local, which was much faster than to use it on testnets. So once again, just create CCP Local Simulator contract like this, compile it, create an instance of a simulator in your test, and then just follow the docs and use simulator in your tests or scripts with Hardhat. That was it for this video. In the next one, we'll explore how we'll do stuff with CCP Local Simulator on fork networks with Foundry and Hardhat, and we'll also have finally a video about local stuff with Remix IDE.